Welcome to Data Science in Python. We're going to talk about the constant that you're adding. So this is part 3 of our video series on regression. What does this constant do? If you're familiar with regression, then you can probably just skip this. But if you're not familiar with it, we're basically adding on our basically y-intercept to this. So I'm going to take and we're going to use the same things that we did last time, NumPy, StatsMods, API, PyPlot. We're going to use the CherryTree dataset. So download that if you haven't. And then we're just going to run this real quick, just like we did last time, to fit a model. Simple enough. Now what we want to do is we want to see what it does if we don't add that. So let's get, I'm going to call it the x variable without the column of ones, which is what you'll see in there when it builds it. So here what we're going to do is we're just going to let little x equal ct1, and we're just going to let it be the diameter. And what we're going to do is exactly what we did here, but we're going to use little x instead. We're not going to add on the constant. Okay, so we're not adding on the constant. Big X has the constant, little x does not. And then we're just going to look at the pictures of it and see what happens in the parameters. So I've got this set up. I should be able to run this directly without any problem. Okay, so let's first look and see the parameters. Okay, so if I wrote over that. That should be CT2. So let's run all this again. Sometimes we make mistakes, and we just got to put up with them. That's why I leave them in these videos, because I want people to understand people make mistakes. And when you make mistakes, it's quite usual, so don't get it too upset. So CT2 res.params, and we'll see what that looks like. And you'll see this has one number for diameter. Okay, CT1 res that does have the constant on it. Let's see what that looks like. So now you have a constant and the diameter. So the constant here is the actual y-intercept. If x equals 0, what's the value for y for our line that we're fitting? So what we probably want to do real quick is just get a visual of this. So we're going to go back and do our plotting just like we did before. So look at a picture so you can actually see what's going on. So we'll plot our data just like we did before. And if you have the code from before, you can probably just copy and paste it. There's no point in typing it again unless you really like typing it again. So here's subplots. And what we can do is originally what we did was we had the data, right? So here we're going to have X and Y. I'm going to do it as O's, circles, and our label will be the data, so that we have a legend on this thing so you can tell between the two. AX plot, and then we're going to put here X, and then what we're going to do is we're going to do CT2 underscore res dot fitted values. Okay, and we're going to make that, how about we make it black? That's what K is, dash dash, and we'll do label equal to no constant. Okay, so when we put this together, and then we're going to copy and paste this and just change this to 1, but let's just look at this real quick. Make sure it works. And notice this line does not go through that data, right? It doesn't, because we're not allowing this intercept to shift. We're not allowing it to shift up and down, so it has to bend the line to best fit the data. Because basically when you don't put in that constant, it forces the line to go through 0, 0. Okay, if we were to extend this out, you would see it would go through 0, 0. But over here you can see that when we plug in 0 for x for the one with the constant, it's going to go through negative 36 on the y-axis, almost negative 37. Okay, so let's just copy and paste this here so we can see what the good line looks like. We're just going to change this to 1 We'll change this to R so we have a red line, and then we'll add in our legend. And I'm going to put the location equals, again here, best. So it'll find the best place for it. So now if I look at this picture that has both lines on it, I can see this red one looks a whole lot better. It actually follows the data, whereas the black one just does not follow the data. And that's what that constant is doing. So if you know, for example, that there should not be a constant and that the data should theoretically go through 0, 0, then I would not add the constant. But in general, always add the constant. Most software does. This software doesn't. So you actually have to do it. All right, so we're going to keep working on regression, move on to the next video, and we'll talk about some diagnostics. But I'll see you there.